All right, let's get back to the whiteboard. Okay, so in chi-square test, it is hypothesis testing. So it's the same problem we're trying to solve that we did last week and the week before. The difference is that we're going to use a different distribution to determine our rejection region. And the step one, what we're trying to test is also different. So before, okay, in the last two sessions, we tested whether, you know, the mean, we'd have a H0, right? We would say, is the average something, right? I'm making up a number 25. H1 is the average not that. And it could also be, you know, greater than, equals to, and less than, etc. We'd also have the case where we were testing proportions. Is it a certain value, 0.2, or is that not equal to 0.2? Now, in this learning unit, you're not exactly testing to see if the population parameter is equal to something, or less than, or greater than something. We're not looking at a specific value. Here we're testing a statement, like we're testing, are two variables independent? And independence means that they don't influence each other, okay, versus dependent. Think of dependent variables as an example. Your consumption of sugar, if you eat more sugar, then your blood sugar level rises. So they are dependent, okay, they're not independent. I'm just going to check the chat. I'm not sure if there was a question. I think not. Sagnipa, okay, welcome. I think your mic is unmuted. I'm not sure if you're going to say anything, but yeah. If not, please mute it. Right. All right, let's begin. So it's the same thing. We are doing hypothesis testing, but we're testing a statement, right? So if you're not sure what I meant by independence, let me know. But I'll give you another example of independence. So I gave you an example of dependent variables, so your consumption of sugar versus your blood sugar levels. But in the same manner, let's say there's two people, A and B. If B eats a lot of sugar, does it influence A's blood sugar level? And the answer is no. Okay, so that's independence. Okay, so if I eat a lot of sugar, it doesn't affect your blood sugar, right? So my consumption of sugar is independent of your blood sugar levels. All right, so hopefully it gives you an idea of what independence is. So in this question, what we're actually trying to test is gender, as in male and female, independent of your motivational level? So that's what you have in your table, the row variables, that is the variables that's going down the rows here, that's gender. So your row variable is gender, and your column variable, going across this way, is motivational levels. Okay, so that's your second variable. So that's what we're going to test for independence. In question A, they ask us to just do a little arithmetic, not involving the hypothesis testing. All right, so let's just read this text first, and I'll explain it to you. The company recently conducted a study in motivation levels. Okay? The HR manager wished to establish if there was any association. So maybe I'll underline that. Association. An association is the same thing as looking for independence or dependence between gender and of an employee and his or her level of motivation. Excuse me. So the following cross tabulation table was compiled from the survey data. So this cross tabulation table shouldn't be new to you, especially with your assignment. You know, you would use this for probabilities. It's the same thing. You comparing two different variables, and you're counting how many people fall in those intersections. So here they're saying 8 people are highly motivated, 8 males are highly motivated, 8 males are moderately motivated, but 14 of them have a low level of motivation. And the same thing for females. We have 19 who are highly motivated and 9 who have a low level of motivation. So the first question A, right, says calculate the row percentage cross tabulation table and show the motivation level of each gender. So looking at these numbers itself isn't an accurate reflection of comparing like with like. And what I mean by that is, yes, you could have 8 males that are highly motivated and a lot more that are females in the same highly motivation level. But in total, it seems like you have a lot more females in total. So you're not really comparing like with like. So the way to compare like with like is to make them all percentages. And how we do that is we'll make them row percentages for question A. That's what they're asking us to do. So in other words, for male, okay, and then we have the high category. High, so let's put a dash there. If we want a percentage, the row percentage, what we're going to do is we're going to divide this by the row total, which we haven't shown here. So row total is just adding this, and this. So 8 plus 8 plus 14, right, will give you, let's see if I don't want to do it in my head. It's 30. Okay, so 30, go back to the table. That value there will be 30. And I'll just do the total for the other one as well. 30. And then for the females, that total is 40. 19, 21, yeah, 31. 31 plus 9 is 40. 40. So let me just double check before I'm going. Yeah, 40. Yeah. So the grand total is 70. Okay. So if I want the percentage of males that are highly motivated, I'm going to take 8 and divide it by the row total, which is 30. And I get the percent, which is, now it's 26.67%. 26. I'm just going to make it 7%, one diff. All right. For moderate, all right, it's going to be the same thing. It's going to be 8, because we've got 8 males, divided by 30, which is 26.7. All right. And then lastly, highly motivated. Oh, no, not high. Low, my bad. About. That percentage is 46.7. Let's do the same thing for females. For females, it's going to be 19 divided by 40 for the first value, and that gives you a percent, 47.5%. All right. And then for moderate, it's 12 over 40, and that gives you 30%. And then lastly, for low level of motivation, it's 22.5%. Now we are comparing like with like, because we're comparing percentages. And if you look at this table, now what it shows, if you notice, let's just look at males, right? Forget females and look at males. You can see the highest percentage for them, right, sits at low level of motivation, quite a high level compared to the other two. It's 46 versus 27. All right. So you can see males predominantly have a low level of motivation, whereas females, it's the opposite. They predominantly have a high level of motivation, looking at these row percentages. Okay, does everyone see that? Does everyone understand it before I move on to question B? All good? Any questions? Good. Okay, that's sick. All right. So let me get back to the whiteboard. Now we're going to answer question B. So question A isn't, it's not often asked in your exam. Question B is, all right? So, and question B is, will contain the bulk of the marks for this type of question. So it's, I wouldn't say don't focus on the type of question A, but it seems pretty easy. Everyone seems to understand it. But question B is pretty much a definite of what you will be asked for chi-squared test, right? So let me clear this out. All right, so question B, let's start with that. Conduct a chi-square test to identify statistically whether there is an association. So in other words, test for independence. That's what they're trying us to do. So underline that, association to the employee's gender and motivation level. That's what the hypothesis test is going to be. And then the second part they tell us is our alpha, or level of significance. So just like last week, for hypothesis testing, we need to be given a level of significance. So it's 10%. All right, that's our alpha. All right, so let's start with step one. Step one is to state your hypothesis. So we always have to be writing. The first one, you're going to have H0. So this is step one, H0. And you're going to have H1. So now, like I said before, we are going to, our hypothesis is going to be in terms of words. It's not going to have a value in it. We're not testing to see if something is equal to something or greater than something. So your H0, I'm going to write this out as text. Your H0 will always be that your variables are independent. Okay, so in other words, our variables are gender. So here H0 is gender and motivation levels are independent. Okay, always remember that. Okay, your H0 will always be the statement that they are independent, and H1 will be the opposite. So if you want, you can just, it's almost like a copy and paste. You can say one of two things for H1. You can say they are dependent, because that's the opposite of independence, if you prefer that. Or you could say that, or you could say gender and motivation levels. So in other words, sorry, my bad, there is an association. There is an association. It is the same thing between gender and motivation. I'm just going to leave a line here. Okay. All right. So your H0 will always be that they're independent. Your H1, you could just say there is an association between gender and motivation levels, or you could say gender and motivation levels are dependent. One of them is fine. Okay, it's up to you which one you want to use. But just remember that H0 will always be the statement that they are independent. All right, so that's just step one. And you don't need to say whether it's a one-tailed or two-tailed test, because the chi-square test is always a one-tailed test, always, right? So this is your step one done. Now we're going to move on to step two. Step two is find the rejection region, all right? Now, there's two things we need to determine our rejection region. One is your alpha, your level of significance. In our case, it's 0.1. Okay, 0.1. And then the second thing is our degrees of freedom, EF. Now, how we determine our degrees of freedom is using this formula here. R minus 1, I'll explain what the R is, R minus 1 into C minus 1. The brackets are very important because you work out what's in the brackets first and then you multiply them. Okay? Your R is simply how many rows do you have? And that's 2 rows. Okay, because you have male and female. So your R is 2, right? And your C would be columns. How many columns do you have? And that's 3. You have high, moderate, and low. So that's pretty much what you see. How many columns do you have? And that's 3. And if you work this out, this becomes 1 times 2, which is just, that's your degrees of freedom. All right, that's how you work it out. All right, so remember, you won't be given this formula, but you need to memorize it. Okay, this is how you determine your degrees of freedom for the test of independence. All right, so we've got our DS, or degrees of freedom, and we've got our alpha. Now we're going to go and find our rejection region. So like I said, this is a chi-square test. In other words, we're going to be working with the chi-square distribution. The chi-square distribution looks like this. Okay, so I'm going to draw the curve. And let me line up a bit bigger. Okay, so skewed. In other words, it peaks on more towards the left, and then it drags out on the right, like that. It's a right skewed distribution, and your rejection region is always on the far right. Okay, so I'll shade it here. This is your rejection region, and the size of this rejection region is the size of alpha, your level of significance. So this is 0.1. That's the size of your rejection region. And the trick now is to work with what is this value here on this axis. And the moment we know that value, then anything to the right of it, anything from there to the right, we would reject H0. And anything on the left, we would accept H0. All right, now let's go and find this unknown value here. Now, remember, our degrees of freedom is 2. Okay, so I'm just going to open up the chi-square table. Please give me a second. It's found right in the back of your textbook, but you'll be given this table as part of your formula sheet. Okay, so here we go. All right, so here it is displayed. Okay, so it's kind of, I know my drawing is not exact like how it is in the textbook, but it's close enough. So we know our alpha is 0.1. So what you see in the table in that first row are all your alpha values. And our alpha value that we're dealing with is 0.1, right? So we're looking at the first column. Okay, we will only look at the first column. Now, which row do we stop at? Well, that's your degrees of freedom, which we worked out to be 2. So it means where your DF is 2, in the first column, we get a value of 4.605. So that is our critical value, 4.605. So here, I'm just going to get that 4.605. All right, so anything bigger than 4.605, we're going to reject H0. Anything lower than that, we will accept H0. All right, so that's your step 2. All right. Okay, now we're going to move on to step 3, and step 3 is going to be the bulk of your workings. Okay, it's going to take most of the time for this question. So I'll take you through it step by step, but please follow along and shout if you're not sure about anything. Okay, so I'm going to erase this to make some space. So step 2 done. I'm going to write it here, step 2. And I'm going to use the space here for step 3. Okay, now to do step 3, we would need the totals for the rows, which we already did, it's 30 and 40. And then we need the total for the columns. So look at just the column high. We're going to add up those values. Okay, so 8 plus 19, we would add them up, and we would get 27. So the total here is 27. The total in the next column is 8 plus 12, which is 20. And in the last column, it's 14 plus 9, which is 23. And 23. All right, and then the grand total, I'm going to put that in a different color so we don't lose track of that. So maybe I'll just use blue. The grand total is adding all of the numbers up in the table, and that'll give you a value of 17. That's our grand total, right? So what we need to do, right, is to work out something called our expected frequency, okay? So our expected frequency is found using this formula here. Okay, so your expected frequency, which is called FE, is found using your row total times your column total. I'll explain how to do this. It's very simple, actually. Divided by the grand total. Divided by your grand total. So, in other words, we're going to create a replica of this table here, all right? But instead of having these values in it, it's going to have the expected frequency. In other words, this is me duplicating the table. So here's your male, there's your female, right? And in the first column, you got highly motivated. I'm just going to put an H for highly motivated. For the middle, it is moderate. And then lastly, it's low. Let me just box this so we keep this. All right. So to work out this value here, that's what we're going to work out. All right. We're going to use this formula here. All right. So let's look at this table. We're looking at male and high. And the row total for males, if you travel along the columns around here, it's 30. That's your row total. So it's going to be 30 times. Now the next thing we're going to work out is your column total. So we're on this column here, because remember we're here now, right? We're trying to work at this. So we're on the first column, H. And the column total for H is 27. It's 27. So it's 30 times 27. And then the grand total never changes. That's the number in blue. That's 70. And if you work this out, you'll get a value of 11.57. So that's what we're going to enter here. 11.57. All right. Okay, that one wasn't clear to you. Let me show you the next one. Maybe this will kind of clarify it. Now let's move on to moderate, and we're still on males. Okay. So here we're going to use the same formula: row total times column total over grand total. Okay. So we're still on males. So the row total for males is 30. That's the row total is 30 times the column total. And now we're on moderate. Okay, so now we're in the middle column. Okay, we're here. Moderate. So moderate, the total for that is 20. Okay, that's the total. So 30 times 20 over the grand total, which is 70, the blue number. And if you work that out, you get a value of, tell me now, 8.57. 8.57. And you do this, you use this formula here for all of them, the remaining 4 values. And if you do that, you'll get a value of, let me do the last one here. I'll populate this. You get 9.86. Okay, so while I'm doing this, I want you to work at this one. Where I put the question mark. You put it in the chat. So you're going to use this formula here. Okay, follow the same method I showed you, right? And tell me what value you get for this question mark here. Just so I can check that you're understanding the method. I'll go back to it. Can you work it out, please? Just want to make sure that you understand that method that I'm showing you. To use the row total times column total or grand total. So I'll give you like 30 seconds and I'm going to do it. Excellent. That is it. That is the value, 13.14. Nicely done. So pretty simple. Okay, 13.14. Nice. Well done. Okay, so that's we're still not there yet. Like I said, step 3, there's a lot of work involved. It's where you get the most amount of marks as well. So it's very important that you understand this step. All right, so now we've got this table, right? And all I'm going to do now is I'm going to rearrange this table. So I'm not doing any calculations. I'm just going to rearrange it differently. Okay, so I'm going to take this out. I'm going to remove this, okay? So I'll write it again, but I'm just writing it differently. Okay, so we got male and we got female. And for each of them, there's 3 categories. They can have a high level of motivation, they can have a moderate level, and they can have a low level. So that's male. Let me just put a line to separate them. Okay. And it's the same thing for females. You have high, you have moderate, and you have low. Right, now in the first column, all I'm going to do is I'm going to write F0, and that is simply just the values that we got in the question, what is given to us. Okay, so here, so in other words, male high is 8 for F0, male moderate is 8. So no calculations, I am just writing it the table in a different way, and I'll show you why in a second. For females, there's 19 that are high, 12 moderate, and 9. 19, 12, and 9, 8, 8, and 14. Right. In the next column, I'm going to write down what we just worked out a minute ago. Give me a second. Create this column. And that was table of expected frequency. Those numbers that you were calculating, that 13.14 that you just worked out, that was for females and for low. So I'm just writing here 13.14. It's all up in the top, 7.57. Next value was 8.57. 9.6. Almost there. And females 13.43. And then lastly, it was 11.4. All right, great. So no calculations that are new so far. I'm just rearranging the table and writing the numbers that we worked out so far. All right. Now the next column that we need to work out, okay, is this here. We're going to subtract these 2 columns. So we're going to say F0 minus FE, and we're going to square it. So in other words, for the first value, we're going to say 8 minus the number for FE, which is 11.57, right? We subtract those 2, and then we square it. Whatever we get, we raise it to the power 2. And if you do that, you'll get a value of 12.76. 12.76. And then I do the same thing for the next row. It's going to be 8 minus 8.57, and I square it. So if I do that for all of them, right? Okay. I'm going to write a few of the numbers here. You kind of get the idea. So it will be, first one will be 12.76. The next one I won't do all of them. It's 0.33. The main important thing is that you understand the method. So on, so on, so on, until you get to the last number, which is 17.16. 17.16. All right, that's the last value. Then the next column, and this is the last column. Okay, we're done after this. This is the last column. And I'll show you why we're working on it now in a second. We're going to take what we got in the previous column. We're going to take what we got here, and we're just going to divide it by FE. So we're just going to divide what we found in the previous column by FE. In other words, F0 minus FE, what we just worked out, and then we just divide it by FE. So this number here, you just divide it by what you got for FE, which is 11.57. So 12.76 divided by 11.57, right, will give you 1.102. 1.102. The next one, the same thing, it's going to be 0.33, right? What we're doing, sorry, 33 divided by 8.57. And that'll give us a value of, gives us a value of 0.038. And you do this all the way to the last row. Okay, so it's going to make some space here. And the last value you should get there is 1.306. All right, and then now that you have all the values you need, the final thing you need to do is just sum these numbers up in the last column. You sum up all these numbers. Okay, so what I'm going to do is I'm going to take away my ugly table here, and I'm going to put a nice neat one for you so you can see it better. I had to write it so you could see the workings. Okay, so I could take you to the workings. All right, so give me a second. This is a much neater table. So let me put it there. Okay, so everything I just did now is written a bit neater here. Okay, so in that last column, okay, in that last column what we just did, all you need to do is add up those numbers. So if you add up all these numbers in the last column, you will get a value of 5.043. Now, all of that work that you just did now to create this table, to work at that 5.043, you're basically working out this formula here. Sum F0 minus FE all squared divided by FE. If you look at the last column, that's, you just ignore this, ignore the summation sign for a second. Just look at everything else here in the block. Everything that you see here is the last column. That's what you worked out. So the last thing you need to do is to sum it up. And that's what you're doing here when I said add all these numbers up. Doing that gives you the answer to this formula that I wrote out here is 5.043. You don't need to memorize this formula. You don't need to memorize it. It's given to you in your formula sheet. But that is the test statistic that you need to work out to determine if you reject or accept your H0. So what you worked out here, you look at where it falls in your step 2 regions. You can see 5 is greater than 4.6. So it's somewhere on the right. It's definitely in the rejection region. So it means we are going to reject H0 because this is bigger than 4.6. So in other words, for step 4, what we're saying is reject H0 because your chi-square test, in other words, this is your chi-square test, is greater than our rejection or the critical value, which is 4.605. All right. So that's your step 4. We reject H0. So based on that, now you could deduct which of these statements is true. Remember, we're saying reject H0. So that means there's H0, we reject it. So that means this one's right. So that means at a 10% level of significance, there's your alpha. At a 10% level of significance, there is an association between gender and motivation levels. That's how you would conclude step 5. Okay, and that is this question done. Is everything clear? Any questions? Does everyone understand the steps that I took you through and how to answer that question? Please let me know. It's very important that you understand this. Got it. Thanks, Nico. Everyone else? All good? Anyone want me to go over anything? Once? Twice? All right. I'm assuming all good. All right. Very good. All right. So glad to hear it. Okay. So this is the test of independence. All right. So for chi-squared test for Learning Unit 9, there's only 3 types of tests that you could have. Right? We've done one of them already. So the test, let me click pause before I start talking. Okay. There's 3 tests. 1, test of independence, which we just did. Second test is test of equal proportions. And the third test is the goodness of fit test. So we've done this one already. These 2 tests are very similar. The only difference is step 1 and step 5. But everything else, the mathematics, the calculations, all of that is the same. And I'll explain test 2 now. This test is a bit different, and I'll cover that in the next session. Okay? So we're only going to go over these 2 tests today. Test of independence and test of equal proportions. All right. The third one, we'll leave it for another session. So let me just open up another board. This is a test of equal proportions. All right. So in this question, they're saying an advertising agency wants to establish whether the proportion of people who read a particular magazine, right, which is called sports news, was the same across 3 geographical areas. A total of 300 readers. Let me just get my status going. There's a total of 300 readers. That's your grand total. All right. Our sports magazine was randomly sampled from the 3 regions, and the readership of sports news was recorded in the following table. All right. So we are going to answer this question here, and this is chi-square test, but now we're testing for equal proportions. So the first question says, formulate the null and alternative hypothesis to test whether the advertising agency can assume equal proportions of readership of sports news across the 3 regions. So remember, for proportions, the symbol is pi. So in other words, your H0, there are 3 regions. So you're testing whether they're the same. That is, the proportion of regions in Eastern Cape, which will say 1. So this will be 1, this will be 2, and this will be 3. Is it equal to pi 2, the readership in Western Cape, which is also equal to KZN, pi 3. This is your H0. Your H1, okay, now be careful, don't get caught in the trap and do this. Don't say pi 1 not equal to pi 2, not equal to pi 3. That's not exactly what we're testing. what we're testing is at least one of them differs. So in other words, what we could have is, we could have pi1 equals to pi2, but they won't be equal to pi3. Or we could switch it around. Maybe this is equal and that's not equal to. So you can't really write all of them out mathematically. What we just need to say by words, all we need to say is very simply, at least one of them differs. That's all you're going to say. At least one differs. That's what you need to say. So your step one, this is different to what we just did earlier in this session. This is the difference between what we did, what we're doing now and what we did earlier for the test of independence. So you can see your step one is different when you're testing for proportions, but everything else is the same. So your step two is going to be the same like what we did earlier. Okay, you find your rejection region. Okay, so to do that, you look at what your alpha is. Okay, what is our alpha? You read the question. Okay, 0.01. So now we're actually answering question B. Question A was just to do this. Right? That's just step one. Now question B wants you to do step 2, 3, 4, and 5. So your alpha is 0.01, in other words, 1%. Your degrees of freedom, like I told you earlier, it's R minus 1 into C minus 1. And so we got 2 rows, 3 columns, just like before. So this would be 2. All right. So now we need to go to our table. Okay, and this is where I'm going to quiz you now. See if you can understand this table. I'll sketch it here. Remember, the size of this rejection region is now 0.01. The size of this alpha is 0.01, and your degrees of freedom is 2. So what is this critical value here? Let me share the table with you, and you write it in the chat. So check what your alpha is. It's 0.01, and your degrees of freedom is 2. So what is the critical value? Can you write it in the chat? I'll give you 30 seconds, because all you're going to do is match the column with the row. So match the alpha with the degrees of freedom, and tell me where they where they intersect. Make it a bit bigger if you know. That's it. Very good. Nicely done. That's right. It's 9.21. Nice. Nice work, people. So our critical value, 9.21. 9.21. So anything bigger than 9.21, we reject H0. And anything less than that, we will accept H0. All right. So the next step, which is step 3, is exactly like how I showed you earlier. So I won't go through the entire process with you, but I'll just show you the answer, because if you understood it for the test of independence, there's exactly the same approach for the test of equal proportions. It's the same method, but now you're going to use this table, okay? This data. You follow those steps. I'm going to clear this here, make some space. All right, and I've done the working for you though, so let me just copy and paste it. So remember what we said, we would do all of the work, create this table, and get the total. You would have this, all of this. All right, now here's the total after getting that last column, which is 7.595. Okay, doing that whole process gives you this total here. So this is your chi-square test. Based on this, and where your rejection region is here, do you accept or reject H0? What do you think? Then write it in the chat. Accept or reject H0. What's your vote? Based on what you found here for your chi-square test. The chi-square test here, if you can't see it, it's 7.595. Do we reject H0 or do we accept H0? Very good. Yes, 7.595 is much less than 9.21. So it's somewhere here. That means it falls in the acceptance region. This is the acceptance region. Oops, accept H0. Anything from here to the right, we reject H0. So this falls in the acceptance region. So that means we accept H0. That means this is correct. And so all we need to do is conclude. Step 5. All right, I'll write the statement out. We always say what significance level we're dealing with. So step 5, we would say at a 1% level, because your alpha is 0.01. Right? So we would say that, and we conclude that there is, we look at the question, okay, we would say there is an equal proportion of readership across the 3 regions. That's your step 5. Because H0 is true. So this is your step 5. Done. Okay, so you can see everything is pretty much the same as what you did earlier. Is this your step 1 and your step 5? That's different. How you conclude and how you write your H0 and H1. Okay, that's what I want to cover this evening. Does that make sense? Everyone understood the content? Please feel free to ask any questions if you want. Thanks, Sarah. So the next session, we're going to finish up with the third test, excuse me, which is the goodness of the test. Okay, and that's the last bit of content for this module. Where is the method used in the real world? Oh, it's very often used. Okay, so let me give you an example, right? One, sometimes you want to test whether 2 variables are associated. Let's say, let me get in the bank. I'll show you an example in the banking sector. Sometimes, instead of like the previous example, you just saw whether someone reads a newspaper or not. But sometimes in the bank, remember the bank gives out loans, okay? So they want to, if the bank gives you a loan, they want to know whether you're going to pay them back, right? That's very, very important information. That will determine whether to give you the loan or not, or also like what's your chance of actually paying them back, all right? So let's say there's the one variable is whether you default on your loan, whether you pay them back or not. 1 means you would default, 0 means you would not, all right? So at least if you're 0, you're a good client. And now there could be a variable that we're trying to measure to see whether it affects this. So let's say this variable could be, I'll create one now. Let's make up which industry sector you're employed in. So are you in government? Okay. Are you in the mining sector? And then another maybe in the medical. You could go quite a lot, quite wide with the industry. So I'm just giving you the, are you in the medical industry? And these are the 3 categories. So your one category is your employment sector. That's your one variable. Sector. And then the row variable is whether you would default. So we want to, the bank would want to know, is there a strong relationship between employment sector and whether you pay them back on a loan? And that's important because if there's no association, that means employment sector doesn't really have a prediction, or it doesn't really say much whether you would default or not. But if they find that there is an association, then they would consider that when granting you the loan when you apply for it. Does that make sense? It's a good question, Stagnigo. That's one example where it's used. But you can, yeah, there's plenty more applications. All right, everyone, that's all I wanted to cover this evening. In the next session, we are going to finish up with the goodness of the test. All right, so please, yeah, watch this video again, hoping it helped you, and actually work through the problem that I did on the board, and then check if your answers correspond to what I have. So that'll consolidate your understanding. All right, if there aren't any questions, remember you can just email me if you do have any questions. But have a good evening, and we will chat soon.